Hi everyone, welcome back to Gary's Casual Repo. This is our second episode, and today we have a special episode with our first co-founders here with me. We have Brad and Lucas. Today they'll be here to talk to us as co-founders of 3M's Creative. Their flagship product, Expanse, is a volumetric sky, fog, and clouds rendering engine in real time for Unity's HDRP. And welcome to the show, Brad and Lucas. It's an honor to have you out here. Why don't you tell us a little bit about yourself first?
Yeah, glad to be on here. Thanks for having us. Yeah.
So, go ahead.
Yeah, just about myself.
Yeah, please.
So I basically our startup is computer graphics oriented, right? And I first got interested in computer graphics at Brown, where we went to school together, right? And I was always kind of into creative programming, that kind of thing, sort of like the intersection between technology and art, making tools for artists, but also was a physics major, and computer graphics kind of was all of those things together, right? So my junior year, I took a computer graphics course. I was like, wow, this is super cool, and I like it a lot. Did a little bit of computer graphics research my senior year, and took a job at Nvidia. Worked there for a little while on their self-driving tech, but it was simulation for self-driving cars. The basic idea is you create a playground for self-driving cars to kill fake people instead of real people, and so that was working a lot kind of adjacent to different parts of Nvidia's rendering stack, right? I specifically was working more on framework code for them, just kind of simulation state management stuff. But at the same time, and beforehand actually a little bit too, I was developing Expanse 1, which was the volumetric sky simulator for Unity's high definition render pipeline. Kind of just as a personal side project because I was interested in it, and had nothing to do because the pandemic was happening at that time, right? I was basically waking up in the morning, working an Nvidia job, and then going for a run, and then coming back and either working on Expanse 1 or playing Cyberpunk 2077.
Great game.
or playing guitar, which I do a lot of too. Activities away from the computer. But I eventually, after finishing the project, decided to release it, and to my surprise, it sort of took off on the Unity Asset Store. Ended up being used in a number of indie films and indie games, in particular the upcoming game from Bossa Games. I think it's called Forbidden Skies or something like that. Actually, it's Lost Skies. That's what it is. And also the game Sons of the Forest, which is up to I think 500,000 or 1 million daily active players, or monthly active players or something. So after having a little bit of success in that department, ended up talking to Lucas about some ideas we had for building a system that was a more general volumetric renderer, and that's how we started working on Expanse 2, which is kind of what we spend most of our development time on now.
So, what led you to reaching out to Lucas for co-founding, to be a co-founder and work on Expanse 2 together?
I mean, we're just friends. We met at a party early on when I moved to San Francisco, and Lucas has a background in a lot of high performance computing and stuff, which is something that I am not particularly good at just on my own. So I don't know if you want to talk a little bit about your background and stuff.
Yeah, I think your background is real. So mostly, I'm a big business guy, and I was just hanging out with Brad. They got some cool ideas I could mooch off, and that kind of worked out. So.
That's fantastic. I've known you guys for a year or two now in the city, right?
Yeah.
So it seems like the synergy is great. But when it comes to working together, right? How did you convince Lucas? Is this something that you were always interested in, computer graphics, rendering, etc. Right?
Yeah.
Or...
Let me give you the backstory. So it's I studied physics and computer science at Harvard, and then I went into more I didn't end up doing that much graphics. I did kind of more general, like low-level systems, kind of high performance computing kind of stuff. Like I was doing like controls and networking code at Nuro for robotics. So like very high performance, like over the network, like deliver controls ways and imitate kind of stuff. So that was pretty interesting. But kind of honestly, it's surprisingly similar to graphics in a lot of ways, where like all these like low-level high performance systems fields are all kind of spiritually similar. Like same with like like HFT, high frequency trading stuff. It's kind of the same thing even.
Yeah.
That's what I really like. And also I had a background in this stuff, but not as much as Brad. And then we had just been friends for a while, and he was just talking to me about like cool ideas he had. I just thought it sounded really interesting. I was kind of fed up with the corporate world.
That's awesome.
I was like, I'll just
good push.
Yeah. And then we just ended up coming with some really cool ideas together. And it sounded like it might actually work. So, and I had enough background that I can kind of catch up. Me and Brad started complement each other pretty well.
Interesting. So Expanse 2, right? This is it's basically for realistic rendering of volumetric gas. And I remember when you all first told me about this, I think when we were going up, like last year during July 4th, when we were traveling together.
Right.
Yep.
I think that the very first question that popped into my head is like, this sounds like a very niche problem that requires a very technical solution, right? Like it's not. I think we've all had experience playing games early on where you go into the sky and you play, and then you start seeing weird stuff in the clouds, etc. So, what led you to set your eyes on like on this problem specifically? I want to tackle this.
Yeah, I mean, I think like being like totally straight about it, like I think it just seemed like an interesting problem, in terms of like especially since the genesis of this whole thing is just a personal project, right? Like I think it ultimately, we weren't really looking for like a hole in the market or anything like that, right? Not really sort of making any kind of like coherent business plan. It was a lot of kind of just like, wow, this seems like kind of like just intrinsically kind of interesting, and I think from there, I think it like I said, I was kind of surprised to see the initial release of the first plugin do well and be useful to people, and then I started to think more about, okay, well, like, there's a lot of like, real-time game engines, right? Like Unreal and Unity are used for like lots of different things now, right? Because essentially they're like, they're like not just artistic tools, but like in some sense they're like reality simulators, right? Or they can be, right?
Yeah.
And so there's lots of sort of different applications where beyond just kind of games, like you might want to sort of simulate like a digital experience. And we realized that like sort of when it comes to volumetric content, the technology to be able to render volumetric content in real time is kind of we're just getting to the point where like consumer GPUs and consumer hardware is powerful enough to do this in any kind of abstract or generic way, right? There have been some algorithmic advancements the past like 5 or so years that have also sort of sped that up, right? And we were kind of just like, well, like at this point we're poised with some background in the field just by chance to kind of be able to build something that might be useful to people, right? So we have some interesting ideas, so we might as well like give it a try, right? But it is very niche and it's like extremely technical, and it's still unclear if it's going to be like super useful to people or not, right? But I think one of the things when you're at least with like very limited amount of experience that like we have in terms of trying to develop ideas, like I feel like I'm starting to get the sense that with the really technical stuff, sometimes you just kind of have to build a prototype to see if it resonates with people, right? So that's kind of the stage we're in right now. Yeah,
just to build on that, I think it's funny because both of us are obviously like very technical, like we study like pure science, right? Neither of us are the kind of people like wanting to found a startup or anything. So it's kind of funny we kind of like neither of us has any idea what we're doing outside of the actual tech.
Yeah.
So we just kind of had this cool project that seemed to work out, and now we're trying to figure out what to do with it.
I mean, it sounds like there's some success in the market, right? Like if it's being used by other developers, that I think that speaks a lot volume. about like people's interest in this, and that it's definitely a problem that's seen by others that requires some sort of special solution and resources piled up behind it, right?
Yeah, I mean the way that the kind of the easiest way to think about it being like, just kind of foundationally useful is that volumetric media is kind of a foundational and distinct content domain like in real-time experiences, right? So it's like it's broadly applicable. Any real-time experience needs to be able to visualize volumetric content in like a reliable and performant way, right? And the question is like, and for years we've faked it in various ways, right? And now we're getting to the point where we can do it reliably for real, right? Sort of for real, I guess the question is like, is it really important enough for people to, consider it being like a more of a lifestyle business, or is it something that like somebody like Unreal or Unity would want to acquire at some point? That's all like but yeah.
Okay, so getting a little bit into the more technical side of things, right? Because even for someone like me who does computer science in other ways, I don't think I have enough of the expertise to really know how technical and how difficult this question is for you guys to break down and provide a solution. So how about a quick 5-minute like graphics rendering 101 so that me and the audience can really visualize that or understand how complex the problem is and what your solution is to that problem.
All right, let me see if I can take this as a challenge for myself.
All right, here we go. Yeah. I don't even know if I can. It's pretty hard. It's a complicated. There's so many different facets to computer graphics, right?
Yeah.
Give it a roll.
All right. So let's like in a really broad sense, like if you're looking at like a picture drawn on screen by like Unreal, right? You're playing a video game, you're looking at like an architectural visualization, whatever, right? You got some stuff rendered on screen. There's like 2 general classifications of like stuff in the scene, like Brad was saying earlier, and like most of it is geometry, right? It's like if you're talking about like you want to render like this table, for example, the way you like mathematically model it is just by its surface, right? You don't really care about anything past the surface.
Yeah.
Even for stuff that's like a little bit, this kind of has a couple layers of code or stuff on top. You can like fake all that, like some tricky math, right? So really, you just care about the geometry of the surface, right? And turns out geometry is like not that expensive to render. And so for the last like 30 years of real-time rendering, basically everything is the geometry. And even like, if you look at like clouds in games, it's like fake geometry, like 99%.
Okay.
Just because it's like mathematically way cheaper to draw on screen. In terms of like the amount of cycles you have to spend, right, to actually do it. The other class is volumetrics, which are different, like for example, clouds, anything like gaseous, even like technically water, but that's usually fake geometry. Volumetrics haven't really had any place in real-time rendering because they just turn out to be mathematically like way more expensive to do, right? Because you actually care about like the whole volume of the object, right? Like if you're looking at a cloud, you have to like take into account all the material like through the cloud and direction, right? So it's just like far more computationally expensive.
It's kind of adding like another, and the reason that that's the case is that when we're talking about computer graphics, we're essentially talking about the way that light interacts with objects, right? It's like we have like a digital camera in the scene. Did something get messed up?
Sorry. My laptop is like locked, so.
Yeah, we're essentially talking about the way that light interacts with stuff in the scene, right? So like, when you're talking about rendering geometry, right? Like you're talking about, a photon or whatever, right? This is like very handy.
1 unit of light.
A photon coming from the sun or from that lamp or something, bouncing off of a surface and then going into your eye, right? So there's only one interaction to model. That's not really true. But there's one interaction to model, right? Because it bounces off the surface and it always bounces off. With volumetric media, light bounces around inside and then scatters into your eye. And so you have to model, like, you basically, and light can do that, like, sort of along the ray, the direction that you're looking right through the cloud or the smoke plume. And so it basically adds, like, another like, I don't know, computational order to the rendering time, right?
It's like another
Gotcha.
dimension.
It's
Another
like
dimension,
another dimension.
exactly. So,
Okay. So it's almost like going from linear 2D to like
It's
exponential.
n squared. Yeah,
Exactly.
yeah.
Right.
It's kind of like n. It's like n to n squared. You know.
Yeah.
Well, arguably more is when I'm taking all the angles.
That's true. Yeah.
Exponential for sure. Yeah.
So that's at least the distinction between kind of like what's called like sort of traditional like polygonal rendering, right? And volumetric rendering, right? Which is what we're working on. It's one of the reasons that extra order of magnitude is one of the reasons why it's so difficult, right?
And to answer your question about how and why it's hard, like as you probably glimpsed a bit, like it's all physics in the end because you're trying to model like the real world, right?
Yeah.
And the real physics of how the actual world works is just way too expensive to actually do. So a lot of the difficulty comes from trying to figure out, like you have to figure out a ton of tricks, right? Because you know you're never actually going to model it correctly.
Yeah, just in general, computer graphics is this weird split between kind of like trying to sort of broadly simulate reality, right? But also make it so that you're only simulating kind of parts of reality, because oftentimes like we use computer graphics for stylized applications, right? Like Pixar or whatever, right? Like sort of. So there's sort of like a question of like how physically based you want something to be, but computer graphics is in many ways the art of just, it's like the art of trying to find hacks to approximate expensive things to compute in reality, right? That visually and perceptually are like tolerable and acceptable as shortcuts. Yeah.
So it sounds like you gotta pick the battles you're trying to fight.
Totally.
You're trying to model the real world, but you can't model everything. So you're trying to get like the principal XYZ elements, model that, and hopefully it gets you close enough to like the reality.
And then you do a bunch of crazy stuff to try to cheat and hope it looks good.
Yeah,
it's one of the reasons why I think like machine learning AI based models have like had such a and are maybe going to like I'm not sure, but like have such a profound impact on the field. It's just because they're so there's already all of these kind of hand tailored heuristics that are perceptual, right?
Yeah.
And if you can replace those with data driven strategies, like I think that's like shown some forms of fruit already.
Absolutely. Yeah.
That's like the ultimate cheating strategy.
To have the data, have the ML model tell you how to cheat.
Exactly.
Better than what we can do.
Was that like enough like of an intro?
No, absolutely.
Cool.
I think that helps conceptualize just how complex the problem is and why it is much less talked about or like have eyes on it compared to like the traditional like geometrics rendering. I was watching some YouTube videos into computer graphics and it was basically saying that all that's happening is just little triangles, right, on the surface.
Yeah.
And that's essentially, we just put more and more triangles to make shapes more and more complex. But yeah, like I couldn't even find that many like YouTube videos or wikis on how volumetrics rendering really works.
Totally.
It seems like a topic that was limited by the compute resources that we have, right? But I guess that's like a perfect segue to go into when you mentioned that like just now that this sort of calculation and computation can be powered by consumer GPUs. How is it that what is it with the newest generation of say like Nvidia chips, right? Like that allows you to make advances on solving this problem.
Yeah, I think there's like a few interesting points here, and you'll have to like back me up on this, so like see if you have any other ideas. And by the way, like both of us are like somewhat new to the world of like hardcore like bare metal GPU programming, so like we're probably gonna get some of this wrong, right? But we're learning and like but
so are we.
But I think one of the sort of more obvious things that's unlocked like a lot of potential, right, that people will talk about like just in all capacities when it comes to GPU programming is the idea of like switching from graphics from GPUs as kind of like a fixed pipeline system, right, where it's like over to like more and more stages of programmable pipelines, right, all the way up to like I think like sometime in the mid 2010s or early 2010s, where you started to be able to just do like kind of abstract parallel computation on GPUs that was not bound by kind of like the preconditions of that was not bound to be related to like rendering algorithms, right? Which is why you can now, like something like CUDA, right, that basically thinks of the GPU as an abstract compute topology for like parallel programming, right? So
I feel like just quick caveat is that like I mean you could hack GPUs to do that stuff like forever.
You could,
but just
you could.
having that be like the focus of like NVIDIA's pushing them ads.
in terms of like easing the programming APIs to
and like making it fast and efficient to do that.
Yeah. So like in computer graphics, like in real-time graphics, like this is like the notion of a compute shader, right? Which basically instead of typically with GPUs, like before that, like you would sort of be bound to what's called like the typical like polygonal rasterization pipeline, where like you basically have your vertices or whatever, that's your triangle mesh data you were like alluding to earlier, that's your surfaces. You pass that to something called like a vertex shader that like transforms those into some camera relative space to be projected onto like a view plane, so that like essentially to be drawn, right? And then they're converted to pixels through a process called rasterization that takes a triangle and turns it into like a little array of shaded blocks, right? And then the sort of one of the first places that programmable GPUs started to become programmable was what happens like depending on what your rendering architecture is, like how what happens like before or after that when light is applied to those pixels to be like to be lit or whatever, and that's where you start to have something like called like programmable shaders, right? But traditionally, and by the way, like probably half of what I just said is like probably subtly wrong in some way, right?
Overall,
so
the idea is just
but now you're not constrained by that anymore. You can just dispatch arbitrary kind of workloads, right, to GPUs, and volumetrics really do not fit into that kind of polygonal rasterization, like that kind of metaphysical world of the description or whatever, right? Of your simulation, and so compute shaders were kind of like one of the ways that it's kind of everything we deal in now is dealing in like compute shaders that allow you to write like very bespoke and custom algorithms for processing stuff. So that's one thing, right? It's just sort of like a capability to even do the kind of work you need to do on the GPU. I think another sort of angle has been the like ray tracing stuff that Nvidia has put out, right? And the fact that they're now optimizing GPUs for ray tracing, right? Because ray tracing is essentially like a very memory bound and memory incoherent workload, right? So you imagine, and by the way, like ray tracing for context, like people who don't know, it's like instead of, it's basically the idea that like when you're rendering an object, you like trace a ray out to where that ray like hits the object, and then you trace it in a whole bunch of different directions trying to accumulate light from all these different light sources, right? And that gives you kind of a more realistic depiction of like things like shadows and things called like global illumination, light bouncing off of other objects, than typical like raster graphics or whatever. Ray tracing is a very memory and coherent workload because you basically draw your line to the object that you're hitting, to this table, right? And especially if this table is really rough and bumpy, you change where that ray goes to, and it will bounce in all sorts of different directions, right? So you have no idea where you're going in the scene next. You're gonna have to grab memory from over there, from like over there, from over there, right? And all that memory, those memory accesses are really incoherent. And Nvidia has done like a lot with their recent generations of GPUs to like improve the way that these really incoherent workloads are processed. And also just to increase like bandwidth or whatever for those incoherent workloads. Volume rendering is really similar, right? In that like you're trying to kind of like process data from a whole bunch of different volumes at once and kind of trace through them, and you don't know which direction you're tracing through them at a given time because it's depending on where you're looking at it from.
Yeah.
So I think that like
It's just indeterministic. It sounds almost like you're always kind of guessing where it's going next, and then depending on how the camera changes, right? AKA like how the player or like any tiny disturbance from the outside world will cause like a cascade of recomputing.
Or even just like a stochastic surface, like something really bumpy kind of. Even if you don't move the camera.
It's very sensitive to
okay.
perturbations.
Even that.
So like say like ideally like what you want for a really coherent workload, right, is like you're rendering, you know, a grid of 16 pixels on next to each other. You want them all to be touching the same memory, kind of, right? Because you want to be able to say, look, we're going to process this all together. All that stuff's going to get into the cache. We're going to look at it all at once, and then we throw it away, right? But you just can't with ray tracing because like each of those 16 pixels could be touching entirely different pieces of geometry and stuff, you know, after the first bounce. So, but volume rendering kind of has a similar structure in that you're trying to, you know, maybe you're not dealing with like accessing lots of different parts of the scene, but you're dealing with accessing lots of different parts of like a big volume texture or whatever, right? So maybe this is not totally, you know, I'm talking about incoherent workloads. Maybe this was an incoherent explanation. but I think but one of the interesting, the kind of takeaway point is that ray tracing is something Nvidia is working on like a lot, right?
Yeah.
And the advances that are, you know, and sort of the considerations they're taking into account for optimizing that also help with volume.
It sounds like
the GPU the same way.
Right. It sounds like the problem and the type of computations that you have to do for both problems are somewhat similar in nature. In that it's hard to predict. It's very sensitive to outside disturbances and very computationally intensive as well.
Yeah.
I would add like one more category of stuff that kind of helps us make this work at all, which is like in terms of like graphics rendering theory, like the last like I don't know what like 10 years something like that has been like kind of categorized by a big push towards like more stochastic rendering techniques rather than like, you know, back like you play like a GameCube game or something and like everything is really deterministic, right? Like you're looking, you know, every pixel is driven by like exactly the piece of texture that like is in that place of the scene. And nowadays like things are really random, right? Like maybe you're doing some really complicated statistical sampling technique and you get like one sample for every 4 pixels or something. You do a bunch of like tricky math to try to like extrapolate the color values. Yeah. And that ends up helping a lot for something like volume rendering where you like need to take advantage of randomness to have any chance of like doing it in real time. And so like all of the field of like rendering theory is now like very kind of well tuned for stochastic problems.
Yeah, it's interesting because to kind of like add to that, like when it comes to rendering geometry, you know, it's very easy to think about the problem of like primary view ray rendering as being totally deterministic. You just look at something and it's either there or it's not, right? But lighting can't really be thought of in that way because once you start thinking about lighting, it's like it becomes kind of a problem of like integrating a really complex distribution. The only way to do that, like, you know, is to do it non-analytically and use Monte Carlo integration, which is like a stochastic process, right? And so, but the fundamental problem of just looking at triangles on the screen does not have to do with that, right? Volumetrics are not that way because even the process of looking through a volume is an integration process. Yeah. It's like you're going through and you're integrating along the view ray. So it's kind of like, it's one of the reasons why, you know, it's like the like lighting is kind of almost as secondary to visualization, right, when it comes to geometry. And so the stochastic methods, you know, are only just been kind of coming into play. But for volumetrics, it's like you don't have a choice.
Yeah. I mean, even just like the underlying like physics of how these things work is all statistical mechanics, right? Like it's deeply statistical.
And like to be fair, like you can integrate these things like using kind of a discrete integration system, you know, like what's typically called ray marching, right? But like, but that has a whole other host of problems, you know, and there's no like absolutes with these things or whatever. Yeah. Like I don't, you know, but the push toward
it's a guessing game.
But the push toward that kind of strategy and philosophy, I think like definitely makes it so that you have things like DLSS, which are meant to denoise stochastic renders of stuff, right? And like our system really can benefit from that, you know.
So we kind of just plug into that existing framework pretty nicely.
I know. I feel like I would throw one more at there, which is just there's been a lot of push recently to like come up with very efficient and fast and kind of low memory footprint representations for volumetric content. You know, like the standard format for volumetrics used in film is something called OpenVDB, volume data something B.
Yeah. Database?
Maybe, yeah, probably volume database.
Volume
That
database,
makes
yeah.
that's definitely. And this is essentially it's a hierarchical like grid basically that sort of like, you know, has tracks various attributes of the volume over the course of like a grid, right? And Nvidia released a paper like around 2020 for something called Nano VDB, which is basically a simpler but incredibly fast representation or version of OpenVDB that runs on the GPU. And Unreal has recently kind of taken that and sort of built their own system that they call sparse volumes. And we were all ready to go and build our own version of Nano VDB for Unreal, but the fact that now Unreal has its own ecosystem for doing that stuff in its own format is one of the reasons why without those advancements, like it would be, the memory bandwidth would just be untenable for trying to render a lot of these things at once.
We got all the pieces in place.
Yeah. And being able to build it on top of Unreal's sparse volume stuff like has been super useful.
To be fair, it is kind of broken. It's
It's maybe
definitely helpful.
Well, that was definitely a lot of details.
Yeah.
I appreciate it. I'll be honest, I think I caught maybe 60% of that. And for viewers who are experts in this, please reach out to me or Brad or Lucas if anything was said was slightly incorrect, so we can correct it.
Oh, I'm like sure.
But also, I think that everything you've touched on, from computational power to the problem with memories to just the underlying theoretical angle of approaching this kind of question, because it's different. It takes a different mindset when you're computing something that you can just brute force versus something that it's impossible, that you have to approximate. So just a very different model of thinking. So the fact that you guys were able to list out all those different advances just shows that you're really plugged into the ecosystem, right? Like both from the theoretical side, like the academic side, to like what's the advances are in the industry. So I thought that was really impressive.
Just because you don't know how wrong it is.
I'm still impressed. Okay, I'm gonna really quickly make sure the camera's working still. I'm not running out of storage or anything.
I've got like 10 minutes.
Yeah, I like try to wrap things up.
You guys also keep going.
Yeah. Okay. I'll get into. So I think we've touched on this a little bit already, but ML and AI was brought up. That is the hottest topic in the Bay Area right now. And I think especially we mentioned Unreal Engine a bunch of times. I remember when Sora was first came out, there was rumors that it was trained on Unreal Engine 5, I think. And one of the most astonishing thing about Sora is that it's very realistic, and it has, you can go into different camera angles, you can have like different characters in it. But based on what you just said, what I'm wondering is, does that mean, excuse me, the current capabilities of AI to generate any sort of volumetrics or even like maybe lighting related things is probably very poor, given that we haven't even solved this question ourselves yet.
Yeah, so
and thus they don't have much to build on in the first place.
I think inherently, like, all these generative AI things are just way too slow for real-time rendering. Like many orders of magnitude too slow, right? Like a Sora video takes like hours on like a compute farm, right? And like you're talking about, you need like milliseconds on like a consumer GPU to be like anywhere close to real-time, right? So like there is a lot of really cool stuff happening with AI in rendering, but none of it is generative yet. I think we're very far off from generative AI, like working in real-time stuff.
Gotcha.
But it's an interesting question that you posed, which is like, if if something like Sora is trained on like synthetically generated data from Unreal, and Unreal doesn't really have like first class support for volumetrics, right?
Right.
Yet, what does that mean, right? I don't really know. You know, I haven't really like played around too much. Well, I mean, obviously, I like Sora, like, you know, I haven't really got used, right?
Need to have fun,
Yeah,
unfortunately.
yeah. And stuff like Dali, right? Like everything I've seen that just messing around with myself, like, is incredibly impressive, right? In terms of like visual fidelity. I'm sure it's trained on like a lot of real world data too. So I think that I mean, my guess would be that like when it comes to volumetrics, like it's probably going to have the same sort of problems when it comes to like lighting inconsistencies and that kind of thing, right? But in terms of like being able to like appear sort of superficially real, which I think a lot of these things are great at doing, right? Superficially, not meaning like it has no value, but just meaning like, you know, it might not really make sense on a structural level, but like but it appears like very real, kind of in aggregate or like in a gestalt way. I feel like it probably is great at that, you know, when it comes to volumetrics. I don't know why it would be any different than like a similar, like very challenging stochastic lighting scenario, right?
Like I think you bring up some really good points about where we still need humans, right? In this world of AI generated content. One thing though that I thought was interesting that Lucas you mentioned was, I think previously you mentioned that for all of these to be like real time, right? Like, because that's also a very important prerequisite when we talk about these technologies. That part of why it's so hard is that it has to be real time and adapt to the changes in the outside factors. It's not like pre-computed and then we just like throw it up. I wonder if in order to achieve that real time effect, you mentioned that randomness is really important. I'm curious to hear if you think AI is something that could help with simulate that randomness to be more accurate or closer to what the real life randomness kind of like what you were mentioning about the superficial real idea.
There's like many dimensions to like how you could imagine doing this, right? And it's again like kind of back to what we were talking about before, where like graphics is a perceptually motivated thing, right? So it's a sort of like we grade it on a perceptual scale often, right? And so it's a very there's a lot of like fruit to be born out of like applying data-driven techniques to graphics. Yeah,
sorry, that's what I have to do.
I think like one really simple thing you can imagine doing is something called like kind of is doing some kind of like post process on a rendered frame. So you kind of render out you know, a version of a video game, right, that's lit using sort of like a standard strategy, you know, like something like Unreal Engine would produce, and then you apply an AI post process to that tries to make it look as real as possible, right, or match a style reference, right. There was a paper that came out a little while back that did this with GTA 5 and had some like very startlingly cool results, you know. There's questions about like the reliability of something like this, right? You know, it's like, can you really get it to look consistent across many hours of like gameplay in a game or visualization in an architecture visualization thing or something like that? That's one avenue, right? There's also the idea of like in terms of just talking about AI and randomness, right? Like one of the things that comes to mind for me is something called like importance sampling in Monte Carlo integration. So kind of this idea that like you're taking, say I'm trying to light this glass surface, right, in a stochastic fashion. You know, the glass is mostly really shiny, right? Yeah. So I know that light is mostly coming from two particular directions. And if I have an analytical model for this glass, I can, even though I'm sampling directions randomly, I can sort of sample more in the important directions, right?
I see.
With something like glass, that's really easy, right? With volumetrics or with like, you know, just other sorts of problems about where in the scene you're trying to sample, these those sort of analytical heuristics are not good enough, and it's a great place to sort of plug in AI models. This is typically called like radiance predicting neural networks, like RPNNs or something. Yeah, there was a paper that came out of Disney Research in 2017 that was all about doing this for multiple scattering volumes, which it was a little bit different. It wasn't really about important sampling light transport paths, but rather it was about trying to simulate light bouncing around many times in a cloud with like but that was very vague, but like that's another area that you could sort of using it to improve sampling strategies in traditional Monte Carlo rendering pipelines. And then a final place I think that like it's obviously very useful is just with content generation. Right?
Absolutely.
So like using things that can be done offline, right? That don't need to be done in real time. Like how do we can use AI to help like accelerate artist workflows or whatever. Ethical considerations.
There's one more fun futuristic one, which is on the topic of Gen AI. Is like years down the line, where these things get way faster and have some kind of stable net representation, you could bake something like an FPGA to make it like really fast.
Yeah.
And then maybe you pass it like like the input to this net is like the triangles in the scene or whatever. You some content domain, it just spits out your frame for you. Or even you have some like net representation of it, right? Of like this is just like I have like the interior of a building, whatever your net representation of that is, and then it just does everything else, right? Like you could imagine it kind of pushing it farther and farther out, and like kind of you just gradually the AI kind of like encroaches on the traditional render pipeline and keeps like knocking stuff off.
You could imagine almost a fixed function pipeline renaissance happening.
Exactly.
It was like very
sort of baked out. But also that's just really difficult because like if the advancements are happening at like a month-to-month clip, who's going to bake something like an FPGA?
It's like very few.
But you don't know, right? Maybe something like
once it gets cheap enough, someone's
eventually.
do it.
Well, or maybe if you're talking about like something like if it's like I don't know, like a volume sampling utility that importance samples a volume, like you could imagine baking that out to like an FPGA, and maybe it's abstract enough that it's still programmable, right?
Yeah.
But I don't know. I mean, this is where you get to the edge of like what I do.
But to be fair, like we're kind of seeing the push towards this direction of like Nvidia now ships like pre-baked nets for like DLSS and stuff, which obviously are not generative and are kind of spiritually in the vein of what Brad was talking about earlier, where it's like you take this one piece of the classic problem that's like really hard to do traditionally, and you just like stick AI like into that really small constrained piece of the problem, and then you bake it out. But so we're already kind of moving that direction of like it's like starting to encroach, and we are getting these like pre-baked nets shipped out. Just that like update rate's still way too high.
Like if there comes a point where DLSS just gets so good that they never want to improve it anymore, then maybe you'll see it in it.
They'll just
on
make
a
it
hardware level.
Right.
I don't know. Yeah, that'd be interesting.
I feel like this is one of those areas of problem that's so interesting, especially in today's age where AI is coming out of everywhere. Where we all know that like these AI models work the best because when they have tons and tons and tons of training data to train them. But clearly, volumetric rendering has been a field that does not have a lot of history or like the amount of data that I would imagine power like a large language model, right? So it's kind of interesting to see like there's this cusp of an AI revolution and then applying it to a problem that may not necessarily have all the data to power like a traditional LLM but still finding interesting ways of integrating like AI into the field to solve problem. I don't know, I just thought that that's like a really cool intersection of where you guys are, especially because it's also almost ironic that you guys deal with GPUs a lot, and all these AI models are being also trained. So there's also this weird like intertwining of like these two areas. That's kind of just why I brought it up.
All right, I actually really have to run. It's like 5:20.
Okay. Should we say this?
It's
just one
just
last thing, or do you need to just dip right now?
Okay.
Yeah.
Dang.
Cool.
Sorry, boys.
But I do want to hear kind of a bit about the dynamic that happens, right? How do you divide responsibilities between you and Lucas? Like what does the day-to-day look like when you have someone that that's shouldering this responsibility with you, but conflicts happens, and when that happens, like how do you deal with it?
Yeah, I mean, luckily, I think like since we're just like kind of friends first and working on this project second, like that always trumps the like questions about like whatever drama there is around like trying to get things to work. We're also just in a phase right now where we're just having fun building something and building a prototype, you know. So I think a lot of the kind of external stressors aren't there, which is both which is great right now. So it feels very like just like there hasn't been so much external pressure to test that yet. But also I think like we have a very solid like kind of work like balance that I think we've struck. We take like Wednesdays off. We just work Monday, Tuesday, Thursday, Friday. But during those days and also kind of just in sometimes on Wednesdays, sometimes on Saturdays, sometimes on Sunday, kind of just like if we get interested in something, going down the rabbit hole, right? Making sure that like you know, I think one of the big things too is that we have complementary skill sets, right? So I have more of kind of the coming from the background of like having built the first plugin and stuff and studying graphic stuff in college, like I have more of the domain knowledge on that stuff. Lucas is like just a significantly better programmer than I am, and also kind of is very good at like parsing and understanding like low level optimization stuff, and also is you know very solid at C++. You know, so I think a lot of like I think I've been teaching him about rendering. He's been teaching me about that stuff, and some of the division of labor goes along those lines. But not all of it. I think the goal is to kind of both understand the whole thing. You know. Because I don't know. That's kind of
Cool.
The end of what I have to say about that.
I guess you originally came up with like the name Expanse, right? What about 3 amps creative?
It's all just like temporary. Like I don't actually know if we're gonna keep any of that stuff. 3M's creative was it was like the Unity publisher store or whatever, like has you put down like a company name. Even at the time it was just me in like, my bedroom and coding. Right? So but it is related to like you know the like misinterpreted and misused and kind of slandered or disrespected book Snow Crash, right? Like people use when they're talking about like the metaverse, right? And in that, I think the main character who's sort of like cornily named hero protagonist has a business card that says like music, movies, and microcode.
Gotcha. Well, so, at least I get to know where the amps are coming from.
We're probably not going to keep that name, but
why not?
And Expanse was just, you know, back originally the version 1 was pretty much focused on simulating skies. And, I just remember thinking like that was kind of a, you know, a good name for something that was trying to capture the scale of atmospheres, right?
Cool. So I guess since we're coming up to the end of the interview, I do want to hear what do you have in store for the future of Expanse, and you know, it sounds like you guys have already gotten some success in having users to use the technologies you're developing. You know, all these movies and games with, you know, a lot of users. Where do you think you're gonna take this business? Like, what's next? For you and Lucas, for the product, for the business.
So we're still putting at least. We're still putting out updates to V1, so we're trying to make sure that that's like still a useful product for people working in HDRP, right, in Unity. I think we're going to continue, like we're just continuing to try to like support that. You know, obviously it's difficult now working on the version 2 in Unreal at the same time, so it's like the clip has slowed there for sure, but definitely trying to continue to support that product. And then with Expanse 2, I think we're sort of at a stage right now where we know that it's useful for sort of semi-real-time / offline stuff, right? So stuff like film VFX and cinematics rendered for games, that kind of thing. but it's still not like quite fast enough to fit into the budget of a game. We know we can get it there. It's just going to take some time to optimize, right? So we're kind of trying to do a two-pronged approach right now where like on one hand, we just finished a push to kind of be quote unquote feature complete, like for the sort of like alpha version, right? Now it's about hunkering down and kind of optimizing it to be able to work fully in real time, right? Which I feel pretty confident we'll be able to do. And on the other hand, sort of just trying to start pitching it to some people who are working on film VFX and stuff. We have right now, like kind of our strongest connection, I think, is somebody who was a VFX director on like Blade Runner 2049 and like a couple of other films.
Okay.
Or like a VFX artist on that. And he's going to be doing some like initial sort of testing for it. But just trying to like, hopefully we'll get, once we're sort of through having him give us some initial feedback and just telling us where it sucks and that's good. Then we'd like to be able to start opening up like a beta program for people to try using it for film VFX workflows.
I'm looking forward to that. Hopefully, I mean, well, I would love to get the beta access and try out, but I also know so little about it that I don't even know if I will be able to make good use of it.
The goal is to make it easy, right? You know, it shouldn't be hard, right? So it'd be super cool to have you try it out and just see what you think.
Where can people like find you and Lucas if they want to connect? Instagram, Twitter, website.
I think like we have a Discord for Expanse version 1, and like we also talk about version 2 there. Like if people want to hop on that, like I can throw you like an invite link.
Yes, absolutely.
Do that. And then I have like, I just made a Twitter account. I like never had a Twitter account before, and now I made one, and I have like 2 followers maybe, but and I never post on there. So
I'll be the third one.
Yeah, maybe that's a bad placement. I want to start posting more about what we're working on there once we kind of have make it through this next stage, right? And if people are just curious, like want to talk about graphics or talk about like making tools for artists or any of that kind of stuff, like we can I'll like throw our emails like down
that'd be great.
in the description or something.
I'll include all of them for the show notes in the description. I think that's gonna wrap up all the topics I have prepared for today. Thank you again for doing this with me, especially doing this in person. Hopefully, you will be able to with the alpha and then the beta. I just wish you and Lucas all the success. So.
Thank you. No, it's really fun to talk about. I think like sometimes when you're working on something like this, you're kind of just like you're so focused on trying to get it to work that like you don't always take a step back and discuss the bigger picture, right? So it's like, and we're also like we're still building it, and so like there's not been a lot of opportunities to talk about it. So it's like fun to talk about.
For sure. Oh, one last thing before I forget. What advice would you have for other people, founders, people that are thinking of doing a startup?
I feel like I have no advice because like this is like my first time trying to like start any kind of business at all. So I feel like don't take advice from me is my first piece of advice. Seriously, but I mean at least what's worked for us so far. And I don't really know if this is something that applies to anybody, right? But we just kind of followed. Maybe this is a piece of advice, I guess, for people who are doing stuff that's like more hard tech or something. And again, like unclear if it's actually that useful, but we just kind of followed something we were interested in, and it makes it really easy to work on it every day. It's like, it feels like we're not at all really in it to like, like go and like be the next like Uber or something, or anything like that. It's like, we're just working on a problem that we think is really interesting and working on something that we think like, like ultimately like contributes to something that we're both passionate about, which is like, media, like film and games and people expressing themselves, right? So like, at the very least, like that makes it really easy to work on every day. It makes it really easy to work on it really, really hard without it feeling like it's just such a slog all the time. So that's worked for us, you know, just kind of following the things that are intrinsically interesting.
Because it's, I mean, yeah, I think just like being able to find that thing that you're interested in, have passion about, will be the biggest motivator for you to wake up and be excited to work on it, right? Like, there's ups and downs. I feel like just working in general, no matter if it's running a startup or working corporate. So finding that core driver of what makes this meaningful for you and Lucas, I think that's a great advice. I think that it's even applicable outside of just startup and entrepreneurship as well. I think all of us is finding that meaningful thing that we want to achieve, and hopefully that will help us, you know, wake up and feeling great about what we're doing.
Yeah, something about enjoying like the process or the act even more than the result or something.
Yeah, exactly.
You know, or both, maybe. Cool. I don't know. Yeah.
Well, thanks again for hopping on and joining me today. And yeah, so that will be episode 2 of Gary's Casual Chat. We'll have more guests coming on in the upcoming months. But thank you for tuning in, and I'll see you next time.
Innovate, break the mold, let's fly away. Together we can shape a brighter day.